Welcome to this webcast of Hawaii IPv6 deployment experiences. My name is Alan Winery. I'm the University of Hawaii Chief Internet Engineer, also President of the IPv6 Forum Hawaii. You can reach me by email as alan.winery@ipv6hawaii.org. This presentation is derived from one that was originally presented at IEEE GLOBECOM in Honolulu, November 2009. A couple of acknowledgments. I'd like to thank Antonio at LavaNet and Bill at Honolulu Community College for their generous sharing of experiences and notes on deploying IPv6 in their organizations. I'd like to thank Latif Ladid and David Lassner for providing me with the opportunity to make this presentation and to participate in the IPv6 Hawaii Forum. Also, the ITS network team, which has embraced Internet Protocol version 6 and has enabled us to deploy it statewide. The system network brings the internet to 18 campuses and learning centers on 6 islands across the state of Hawaii, as well as approximately 50 separate research and outreach facilities. We are the ISP for state government and the Bishop Museum, and the Internet 2 connector for the Department of Education and NOAA National Weather Service Forecast Office and National Marine Fisheries Service. This is a philosophy slide for you. IPv6 is not a project. This is kind of a mantra to keep saying to yourself as you go, because we don't have an IPv6 person or an IPv6 team or an IPv6 initiative. It's our policy to deploy IPv6 where we deploy IP version 4. As upgrades or maintenance or changes are scheduled, IPv6 is on the to-do list. Some advice about proceeding with the deployment of IPv6: start now. Do not forklift. In other words, don't go out and replace everything that's not ready for IPv6 right now, because that will cost money. And you can mitigate cost by considering IPv6 in the course of your design and purchasing decisions, and work towards including IPv6 in what you do. Most things you will find once you get into it, people don't realize how IPv6 ready most devices are right now. Just in the last 2 years, there really has been great gains in IPv6 readiness. Right now, any new client operating systems are probably IPv6 compatible. If you have Windows XP, you can do v6 with it, Vista or 7, Mac OS, pretty much any version of Mac OS. Routers and switches, Cisco, Juniper, Brocade, which is the company that absorbed Foundry Networks a while back. Server implementations, Linux, Solaris, Windows 2003 and 08, Mac OS 10 servers, Apache Web Server, Bind Name Server, Postfix, SendMail, probably many other things that I have neglected to mention. But you'll just find that v6 support is already more and more pervasive, and it's already in the things that you have right now. This is a slide to show you distribution of University of Hawaii facilities across the state of Hawaii for perspective in what I'm about to talk about. Of course, these dots are probably bigger than most cities in Hawaii, so each dot probably represents several facilities, or some represent several facilities, but it's just a general scope and breadth visualization. This is a picture of the University of Hawaii network backbone. There are 2 of them. One, the blue one, is the microwave backbone, which went in production in 2002. It operates at OC3, or 155 megabits per second rate. And the green one is under the ocean on fiber, and that is a 10 gigabit interconnect between each of the islands shown. And of that 10 gigabits, we get 1 gigabit connections. That network is shared between the Department of Education, the State of Hawaii, and the University of Hawaii, and each takes a 1 gigabit Ethernet drop. This is a picture of our trans-Pacific REN connections. The thicker, more prominent blue lines comprise the Southern Transport born 10 gig links, which we acquired as a result of our partnership with ARNet, the Australian Research and Education Network. And the North Path, which is right here, goes through Honolulu from Sydney to Honolulu to Seattle, is 10 gig all the way through. We access that at 10 gigabits. And the South Path, which goes from Sydney to the Big Island to Los Angeles, we tap into that at 1 gigabit per second to support Mauna Kea observatories on the Big Island of Hawaii. A little bit of IPv6 history as it relates to the University of Hawaii. In January of '04, our peerings with 3 research and education networks. We did demos to Korea and Japan as part of the Techs in Paradise 2004 conference. And those demos and that conference really drove us to initially turn on IPv6. That was our first. It was both a driver, and we were thankful for a driver, thankful for a reason to prioritize it. In December of '07, we acquired our own addresses, and in 2008, we turned on statewide IPv6 routing and addressing. Watershed moments in our V6 deployment history. We acquired an address block of our own in December 2007. In 2008, our long-awaited Cisco IOS for Catalyst 6500 and 3750 permitted us to go native on most core infrastructure. We waited for quite a while for loads for 6500, as did many organizations. And in June 2009, we added IPv6 to our TW Telecom peering, which made commodity IPv6 viable. So prior to that time, we had no commodity. When I say commodity, I mean non-research and education networks, no commodity peering for IP version 6. So prior to that, we had only research and education connections to IPv6, and therefore if we had connections to things like Google, IPv6.google.com, or other commercial sites at all, they would flow through Australia or Japan. And so that June 2009 peering with TW Telecom is a really important watershed moment in our deployment history. Our current status for IPv6 deployment at the University of Hawaii, our DNS stores and answers forward and reverse IPv6 records containing IPv6 information. Forwards records currently are served only in IP version 4 packets. Reverses are currently served in IP version 4 and IP version 6 packets. Statewide, 99% of our facility gateway routers have IPv6. 3 campuses have deployed IPv6 in some form: Manoa, Honolulu, and Maui Community College. And UH Manoa has native v6 turned on to all user segments. It's a bit surprising that this is our list of problems for native v6 deployment to user networks, meaning we turned on IPv6 native to all segments on the Manoa campus, and we honestly have not had a single problem or a single call, or none that we've identified. And so it just shows you that if you go to set up a well configured dual stack network, it can be relatively problem free.